Welcome back, my dear student. What a joy to see you back. How was the quiz? Good. I'm so proud of you. Well, in this up lesson, we're going to talk about concept of ratio of three quantities. Now, previous lesson, we learned two quantities. Now, what is three quantities? Let's say, for example, let's take the American football. Okay, so we got Mr. Mac got one American football and then one shuttlecock, and then I got three ping pong balls. See that? I got three ping pong balls. So what's the ratio? 1, 1, 3. See that? Now, doesn't mean when you have three quantities, the numbers has to be different. You can't have 1, 1, 3 or 1, 2, 2, things like that. The thing is, each quantity, each item represent different quantity, the ratio. See that? So in this case, the American football represent 1, the shuttlecock represent 1, and the ping pong balls represent 3. And that's the ratio, okay? So let's write that down. Okay, let Mr. Mike to write down. Let me put this one down. Okay, if I have to write it. So the ratio is what again? 1, 1, 3. So we know that the first one is the football. Okay, the first one is the football we're referring to, and the second one is the shuttlecock. Okay, so the second one is the shuttlecock, and then the third one is the ping pong ball. All right, ping pong ball. All right, there we go. Okay, there we go. So we got three items we are referring: the football, the shuttlecock, and the three ping pong balls. All right, so that makes it the ratio 1, 1, 3. Okay, Mr. Max is going to show you another scenario where we're going to use three quantities. Okay, here it is. All right, we want to do some cooking this time. Mr. Max, bring this table here. Okay, well, we're going to see how in cooking, when mom cooks, how she uses ratio in her spices. All right, how ratio has been utilized. Okay, we're going to today cook. Well, this is not a real recipe. Mr. Mac just going to show you a sample. All right, okay, this is the banana flour. Okay, we're going to cook a banana flour today. All right, so what do? We pull all these flours. Okay, we throw them in. Alright, so we're going to put all this flour in there. Now let's say Mr. Mac pulled everything out, throw that in there, and then keep in mind there is something inside. That there's two parts you got to pull it out. Alright, I'm sure your mom knows that. Okay, so and then let's say we already done all that. Now we're going to put the spices in there. So a friend of Mr. Mac told how to make this banana flour dish. Okay, so she told me that I need to use 1 teaspoon of salt. Okay, so let's take 1 teaspoon of salt. Okay, and then 2 teaspoon of chili powders. Okay, 2 teaspoon of chili powders. All right, so okay, so let's put 2 teaspoon of chili powders. Oh, looks so red. Oh, looks so good too. It's going to be very hot, spicy. All right, 2 teaspoon of chili powders, and then 4 teaspoon of turmeric powders. All right, okay, there we go. We're going to take 4 teaspoon of turmeric powder. Okay, that's 1, and then that's 2, and that's 3, and that's 4. See that? So that's the ratio. Now that makes into like a recipe. See that? The recipe is to make this banana flour dish. I need 1 teaspoon of salt, 2 teaspoon of chili powder, and 4 teaspoon of turmeric powder. So let's see Mr. Mac to write that down. Okay, so it's 1 ratio to what? 2 ratio to 4. See that? So 1 salt. Okay, salt, and then chili powder. Okay, and then what is this one? Is turmeric powder. Exactly. All right, the ratio is 1, 2, 4. Now what happens? Let's see Mr. Max realize there's going to be more people coming over. Mr. Mac want to make more banana flour dish. So Mr. Mac increased it. I said, okay, let's double it. All right. So the recipe that my friend she gave me was only for 1 flour, but Mr. Mac's going to do 2 flours. All right. So what do? Again, I open them, throw all these flours in there, remove them, cut them, and then I'm going to put the spices. Okay, I already put the first part of the ratio 1, 2, 4, which was meant for 1 flour. Now I have 2 flour. That means what? I have to double it. Proportion. See that? It's a proportion. So now I have to double it. So what I have to do? Again, I have to use 1 more teaspoon. Okay, that means a total of 2 2 teaspoons of salt already been added. See that? Now we got 2 teaspoons. One more. I'm adding another more. So now we got 2. So what about the chili? Another 2. That makes how many total? 4. 4. My goodness, it's gonna be it's gonna be hot. It's gonna be spicy. Alright, 4. And then total 4 because you're adding another 2. Now how about turmeric powder? Another 4 more. So that makes it 8 total. See that? So we can put another 4 more because we had doubled the flour, the banana flour. So that's 2 and that's a 3 and that is 4. See that? So that's where the proportion comes into play. So now when I doubled, this was for 1 banana, okay, banana flour. So when I doubled it, okay, when it becomes 2, the ratio becomes 2, 4 and 8. See that? They're still equivalent. The ratio is still equivalent. But the proportion, because of from 1 banana flour I went to 2 banana flours, I doubled it. The ratio now is 2, 4, 8. How do I know this is still equivalent? Because if I had to divide the 2 with 2, it gives you what? 1. I divide the 4 by 2, gives me 2. I divide the 8 by 2, gives me 4. See that? There's still equivalent ratio. It's the proportion. Because I doubled it, I doubled the ratio. So that's why it's so important. Now you can go tell your mom, Mom, do you know that you use mathematics in your cooking? She's going to look at you, yeah, Mom, you the ratio. When she makes a dish, she's using ratio because you got to keep it in proportion. If you put too much salt, what happens? It's going to be too salty. You put too much spices or less spices, it's not going to be proper taste. Am I right? The spiciness is not going to be there. Like Mr. Mac to put too much chili in it. What's going to happen? It's going to be so hot. I'm going to drink a lot of water after I eat the dish. All my friends I have to put a lot of ice water especially, okay? So that's why it's very important, the proportion. That's why the recipe, when you look at the recipe, they have a proportion. It's already been set. They say this is it. This is the proportion you want to use. If you increase it, let's say the serving increase it from 4 to 8, you double it. See that? Because from 4 to 8, they double the number. See what I'm saying? Alright, good. Well, my dear student, let Mr. Mac put this away and let's talk about more. This time we'll talk about the equivalent ratio, okay? The proportion. And I'll be back with you in a few seconds. Alright, my dear student, did you notice that? That 1, 2, 4 is equivalent fraction to 2, 4, 8. How do you prove that? One way of proving that is, you simplify this. You find a common number that you can divide all this 2, 4 and 8, which will be 2. When I divide 2 by 2, gives me 1. When I divide 4 by 2, gives me 2. When I divide 8 by 2, gives me 4. That makes this 2 a equivalent fraction. Okay, now very important, you have to have a common number, one common number dividing all this to simplify it, to prove it the equivalent fraction. Let's say for example, let's do another example. Okay, Mr. Mac have 1 football and 1 shuttlecock, and then I got 3 ping pong balls. Alright, okay, so now let's say for example Mr. Mac to increase the ratio. Okay, the ratio is 1, 1, 3. So now if I to say I got 2 American football, drop the ping pong ball. Okay, I got 2 American football, and then I got 2 shuttlecock, and then I got 6 ping pong balls. Alright, let me see if I can grab all the 6. Okay, I'll put one here. Let's see if I can grab all 6 of them. Alright, there we go. I got 5 in my hand, alright, and then one here, 6. Okay, so there's 6 ping pong balls. So now we want to see the ratio. Are they equivalent ratio? The first one is what? 1, 1, 3. Now I got 2, 2, 6. Alright, let's see if they both are equivalent fractions. Okay, so let Mr. Mac put this away. Alright, let me put this away. Okay, so let's put that numbers on the board. Alright, let's put the numbers on the board. Okay, so we know the first one was 1, 1, 3. And then we increased it. The second scenario was what? 2, 2, 6. in order to prove the equivalent fraction, I have to reduce this, find a common number, alright? Okay, now let's say for example, let's start with this one. I say, alright, let's try 3. I can divide 6 by 3, am I right? But 2 cannot divide by 3. This cannot divide by 3. See that? That's why you got to find the common number that all 3 can be divided. Alright? Which would be 2. 2 divided by 2 is what? 1. 2 divided by 2 is 1. 6 divided by 2 is 3. So these two are equivalent ratio, okay? So equivalent, alright? Equivalent ratios. Equivalent ratios. Now what about this two? Yes, we proved it. We proved it. This is also equivalent ratios, alright? Okay, so it's very important, alright? In order to reduce, you have to find a common number. Okay, let's say for example, Mr. Mac to give you 8, 16 and 24. I want to simplify this ratio. So what would be the most common, the biggest common, I should say, the biggest common that I can reduce this down? Well, let's see. 8 can be divided by 8, 16 can divide by 8, 24 can divide by 8. See that? Well, you say, Mr. Mac, why don't I start with 2? Yes, you can do 2, but 8 will take you to the answer right away. Let's say 8 divided by 8 is 1, 16 divided by 8 is 2, 24 divided by 8 is 3. See that? Now, you could use the, like you said, 2, and then let's say, for example, if I divide 8 by 2 gives me 4, 16 divided by 2 gives me 8, 24 divided by 2 is give me 12. I can reduce more. See that? I can do it again, another 2. 4 divided by 2 is 2, 8 divided by 2 is 4, 12 divided by 2 is 6. I can reduce further. So again, I can do 2. 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. Back to that. But if you find the biggest common number that can divide all 3, will take you to the answer right away, rather than you doing this. Okay? See that? Alright? So try to find the biggest common, alright? That all 3 can be divided and you'll get to the simplest form. Alright? Okay, good. Well, let Mr. Mac erase the board and let's talk more about ratios. 3 quantity ratios, and I'll be back with you in a few seconds. Alright, my dear student, let's say Mr. Mac give you a pair of ratios. Okay, let's say for example, I give you 3 and then 15 and then 21. And also I told you compare that with, let's say, 1, 5 and 7. I want to see if these two ratios are equivalent. Now how do I prove that? That these two ratios are equivalent? Exactly. I have to reduce this down. Reduce this down such a way it will show us as 1 to 5 to 7. Okay? If this reduced down to 1 to 5 to 7, then they're equivalent ratios. If not, they're not. Okay? So how do I reduce that? Exactly, I divide it. First I find a common number that all these 3 numbers can be divided by. So what would be the common number? 3, 15 and 21. Always look at the smallest number. So 3 can be divided by 3, okay? Because there's no anything else other than 3 can be divided. That means, say 15 can be divided by 3. Yes. How about 21? Yes, okay? So let's do that. So we're going to divide all this by 3. Okay? So 3 divided by 3 is 1. 15 divided by 3 is 5. 21 divided by 3 is 7. What does that tell you? They are equivalent fraction. See that? So they are equivalent, alright? So it's very important, okay, to reduce the bigger ratios and down so that you can see their equivalent ratios, alright? Okay, good. Now let's do another one. Let's say Mr. Mac to give you 4 and then 5 and then 9, okay? I want you to compare that with, let's say if I give you, let's say 20, 25 and 45. So what do? The best way is always start with this one, okay? Even though I give you this order, don't start with the smallest, go to the big one. See if you can reduce that down to that. It'll be much easier, okay? So ask yourself, what would be a common number that can divide all this? By looking at 0, 5 and 5 on the place value on the end of each number, that tells you all these 3 can be divided by what? 5. There you go, see that? Because 20 can be divided by 5, 25 can divide by 5, 45 can divide by 5. So let's do that. Let's divide all this by 5, okay? Okay, 5 and 5. So what happens? 20 divided by 5 is what? 4. 25 divided by 5 is 5. and 45 divided by 5 is 9. Now let's compare that. Yes, they are equivalent. So what that tells you, these two ratios are equivalent. Alright, my dear students, let's take another scenario, okay? This time, if I had to give you a ratio of two quantities and two ratios, alright? And I want you to combine that into a one ratio with three quantities. What do I mean by that? Let's say, for example, Mr. Mac to tell you the ratio, okay, of an American football and a shuttlecock is 1 to 1. Alright? Okay, so let's write that down. Okay, the ratio is what? 1 to 1. Okay, 1, 1. And that's the football with the, exactly, shuttlecock. Okay, so we got 1 to 1. Alright, then I give you another scenario. Okay, this time Mr. Mac take this ratio of a shuttlecock 1 and a ping pong ball is 1 to 3. Okay, so let's write that down. So 1 to 3. Okay, so 1 to 3. So which is this one, we know that is what? Shuttlecock. Okay, so shuttlecock, and then, and this one is the ping pong ball. Alright, ping pong ball. Alright, there we go. Okay, so now we want to combine this into one ratio with three quantities. How do we do that? Now look at this. Football and shuttlecock and ping pong. That tells you we can create a relation between this ratio and that ratio. Look at that, shuttlecock and shuttlecock. 1 and 1. This 1 is referring to one football. This 1 is referring to three ping pong ball. That means I can line it up like this. 1, 1, 1, 3. Look at this. Because this is shuttlecock and shuttlecock. That means I can write 1 ratio 3. That makes one football to one shuttlecock to three ping pong balls. See that? So I combine the two ratios with two quantities into one ratio with three quantities. Does that make sense? Alright? Okay, let Mr. Mac erase the board. Let's do more, okay? Pretty straightforward, isn't it? I'll be back with you in a few seconds. My dear student, now let's take the scenario earlier when we were cooking that banana flour. Now let's use that recipe. Now what was the recipe ratio was? Okay, we have given 1 teaspoon of salt with 2 teaspoon of chili powders. Okay, all right, let Mr. Mac just give you two quantities. Okay, ratio. All right, so we know this is the salt and this is the chili powder. All right, chili powder. And then let's say Mr. Mac give you another ratio, which is the 2 of chili powder with 4 turmeric powder. Alright, so we know this is chili powder, and this one is the turmeric powder. Okay, turmeric powder. And I want to combine this into one ratio with three quantities. Because why? Look at that, salt, chili powder, turmeric. That's how many. So there are only what? Three quantities, because chili powder is repeating twice. So that means I can line it up like this. 1 ratio 2. See the chili powder, I put like this. 2 ratio 4. Now look at that. 1, 2, and 4. See that? I combine that two ratios with two quantities into one ratio with three quantities. So now it's 1, 2, and 4. Now what happened if Mr. Mac this time told you that the first ratio I give you is the 1 to 2. The salt is 1 teaspoon, and the 2 is for the 2 teaspoon of chili powder. Alright? And then another ratio I gave you is 4. Let's say we doubled the flour, okay, the banana flours. Alright? We doubled it and it gave you 4 ratio 8. I told you 4 chili powder, and then to 8 turmeric powder. Now we still got three items: salt, chili powder, and turmeric powder. See that? So let's go and line it up. Okay, let's line it up. 1 ratio 2, and then the chili powder. Okay, I want to put it right below it. 4 ratio 8. But look at this, the number are not same. So what do you have to do? You have to either double this or reduce this. such a way that the number will be same to make it to the same ratio. Okay, if I to double this, I times all this by 2, so that makes 2:4, and then 4:8. Then I can combine. As long as these two are same, then I can combine. I can write down 2:4:8. Or I divide all this by 2. Okay, so I divide all this by 2, so that makes it, the top one is 1:2, the bottom one will be 4 divided by 2 is what? 2. 8 divided by 2 is 4. So now it's 1:2:4. The key is what? These two has to be identical in order to combine them into one ratio with 3 quantities. That's very important. See that? Because look, that's 1:2. This is 4:8. But both are chili powder. See that? But I cannot combine them. Why? Because the ratio is 2 and 4, the number wise. See that? So I have to convert either top by multiplying 2 to get 2:4, or divide the bottom by 2:4. Okay? So that will reduce that 4:8 into 2:4. See that? So now look, they both are same. Now I can combine, or both the same. When you have this for 2 flowers, when you have this for 1 flower, that means if you usually you want to reduce it. Once you combine, you reduce it down. If you cannot reduce it down, leave it the way it is. Okay, let's do another example. Okay, let's say Mr. Mac to give you. Okay, one ratio is 1, 3, and another ratio. Let's say this is the football. Okay, let's say this is football, and this one is the shuttlecock. Okay, and then I give you another ratio. Okay, let's say I told you it's let's say 6 and 5. All right, 6 and 5. All right, the 6 is the shuttlecock, and 5 is the ping pong ball. And I want to combine them into one ratio with 3 quantities. See that? Because football, shuttlecock is same thing. So how many items are there? 1, 2, 3. Okay, so now let's line it up. Line it up by the shuttlecock straight down. Okay, what I mean by that, let's put 1:3. That's the shuttlecock right there. So that means I'm going to grab this one, line it up right there. So 6:5. Now look at this. This is 6 and this is 3. We can't combine yet. We have to convert this into 6 by multiplying this by what? 2. This whole thing by 2. You have to multiply the whole thing. You cannot just multiply the 3 by 2. You also have to multiply 1 also by 2. So that makes it 2:6, and rewrite this one 6:5. Now they both are same. Now I can write out 2:6:5. So in other words, 2 to 6, 6 to 5. There you go. We combined it. That means 2 football, 6 shuttlecocks, and 5 ping pong balls. See that? That's the ratio. If I give you like this. Now can I divide? No, I cannot, because 5, let's say if I want to reduce down to this to 3, and I try to divide this by 3, yes I can, but what about 5? 5 cannot be divided. That's why I multiplied it rather than dividing it. Because I can't simplify. 2, 6 and 5. Is there a common number I can divide 2, 6 and 5? No. Because I can divide 2 by 2 and 6 by 2, but not 5. Because we cannot have decimal or fraction in ratios. Always whole number, round number. Alright? Okay, good. Alright, good. Alright, my dear student, let Mr. Mac erase the board and let's learn more about ratios involving 3 quantities. And I'll be back with you in a few seconds. Alright, my dear student, this part of the sub-lesson we're going to talk about, let's say Mr. Mac, to show you this bag right here, okay? In this bag, Mr. Mac told you I got 15 balls, alright? Okay, so consider of the American football, the ping pong balls, and the shuttlecock, alright? So I said there are 15 of them. But I didn't tell you what is the individual quantity, but I gave you the ratio. I gave you the ratio. The ratio is 1, 1, 3. So 1 to 1 to 3. That means 1 football, the American football, okay? And then 1 shuttlecock. And then 3 ping pong balls, all right? All right, okay, that's the ratio. And I told you what's the total number of balls in this bag. 15, okay? So I told you that 15 balls in the bag, okay? 15 balls, all right? I want to find out how many football, how many shuttlecock, and how many ping pong balls in this bag. So how do I do that? Exactly. Add them. Add all this, okay? So what we do is we're going to add all this ratio. 1 plus 1 plus 3. That makes it 1 plus 1 is 2. 2 plus 3 is 5. Okay? So there are 5 parts, which we're going to divide that 15 into 5 parts. This is 1 part, another 1 part, and this is 3 parts. So we total up come to 5 parts. So we're going to break that 15 into 5 parts. That means 15 divided by 5. So 15 divided by 5, that gives you what? Exactly 3. So each part represents 3. That means 1 times 3 is what? It's 3. So there are 3 football. 1 times 3, exactly 3 shuttlecock. 3 times 3, that means 9 ping pong balls. And when you add 3 plus 3 is 6, 6 plus 9 is 15. See that? So now let's look at that. Okay, let's, Mr. Mac, grab the basket. Okay, let's see. We got 1 football, 2, oops, throwing it on the floor. 2 football, and then we got 3 football, and there you go. So that represents 3, okay? So now let's look at the shuttlecock. We got 1, all right, and then we got 2, and that is 3 right there, okay? So there's no more shuttlecock, that's 3. And then let's see how many ping pong ball. 1 ping pong ball, oops, and then 2 ping pong ball, 3 ping pong balls, and then 4 ping pong balls, 5 ping pong balls, 6 ping pong balls, 7 ping pong balls, 8 ping pong balls, and finally 9 ping pong balls. I said right there. See that? Okay. So there we go. Okay. See that? So let's give another example. Okay. Let's say Mr. Mac to give you. All right. The ratio is 2, and then 5, and then let's say 7. All right. So I told you the ratio of, let's say, in this case, football. All right. 2 football, 5 shuttlecocks, and 7 ping pong balls. All right, and I told you there are total of 140 balls. 140 balls. I want to find out what 2, 5, and 7 represent. How many footballs in that bag? How many shuttlecocks in the bag? And how many ping pong balls in the bag? So what do? Exactly, we combine this. 2 plus 5 plus 7. 2 plus 5 is 7. 7 plus 7 is 14. So that makes it 14. Alright? So that means there are 14 parts. And we're going to break that 140 into 14 parts. And each part represent for the football, for the shuttlecock, and the ping pong. Alright? So that means there's 2 parts for football, 5 parts for the shuttlecocks, and 7 parts for the ping pong balls. Alright, so what do? We want to divide 140 with 14. Okay, such a big number like this, you use the long division method. When I say long division, we're going to use the cage approach. Alright, so 440 is kind of into Mr. Mac. I'm going to put it inside the cage, and 14 is kind of out. I'll put outside the cage. Okay, 1, I cannot go to the next digit. 14, there's how many 14? 1. 1 times 14 is 14. Minus give me 0. When you minus give you 0, there's a 0 on the end, just bring it up. That means each part represents 10. So 2 times 10 exactly makes what? 20. There are 20 football. 5 times 10 gives you 50. There are 50 football. 50 shuttlecocks. 7 times 10, there are 70 ping pong balls. So that's the ratio, 20, 50, 70. When you reduce it down to come down to 2, 5, and 7. Alright, these 2 are equivalent ratios. Alright, so that's how you do it. Pretty easy, isn't it? Alright, let's erase the board and let's learn more. It's gonna be, isn't it fun? Ratio is fun. I'll be back with you in a few seconds. Alright, my dear student, now this time, let's say for example, Mr. Mac, can I show you? Look at this basket, look at that. Okay, right away, can you see how many football inside the basket or in the bag? There are 2 of them, see that? But you cannot tell how many shuttlecock or the ping pong ball, alright, because it's kind of small, alright, but the football is big, you can tell right away there's a 2. But I gave you the ratio, I told you the ratio is 1, 1, 3. That means 1 football, 1 shuttlecock, and 3 ping pong balls. Alright, so let's say you know the ratio. Alright, that's the ratio 1, 1, 3. But from the back you can right away tell there are 2 footballs. Alright, so but you want to find out how many shuttlecock and how many ping pong balls are there in the back, in this bag. But you know 2 football right away. Okay, so that means we say 2, but we don't know what this and this going to be because it's inside the bag. Alright, but by mathematically we want to find it out. So how do I go from 1 to 2? I multiply that by 2, am I right? If I multiply 1, the first part of the ratio, the quantity, with 2, I have to multiply everything by 2. See that? So that means 1 times 2 is 2, 1 times 2 is 2, 3 times 2 is 6. So now there are 2 shuttlecock and 6 ping pong balls. Alright, so let's do that. Let's count it, okay? So we know we got 1 football, alright? We got 2 football, and then look at that. 1 shuttlecock, and then 2 shuttlecock. See that? Now let's see how many ping pong balls. 1 ping pong ball, 2 ping pong ball, 3 ping pong ball, 4 ping pong ball, 5 ping pong balls, and finally the winner is the 6 ping pong balls. Alright, see that got 6, okay? So right there, 2, 2, 6. So if I just give you 1, alright, after I gave you the ratio and told you only the right quantity, the amount, the quantity of the football is 2, you should able to find for shuttlecock and the ping pong balls. Alright, let's do another one. Okay, let's say Mr. Mac to tell you the ratio is that, and in the back there are 5 football. Okay, so I want to find out how many. Alright, okay, let's do this. Let's not always pick the football. Let's say this time I told you that the shuttlecock, let's say ping pong ball. Okay, let's say the ping pong ball there are 9. Okay, I want you to find out how many football and how many shuttlecocks in the back. So first ask yourself, from 3 to 9, what do I multiply 3 with not to get to 9? 3, because 3 times 3 is what? 9. Okay, so that means I'm going to multiply all of them by 3. So 3 times 3 is 9, 3 times 1 is 3, 3 times 1 is 3. That means if I told you this is the ratio for football, shuttlecock and ping pong ball, if the one of the quantity changes, the number that you're multiplying to change to that, okay, has to be multiplied to the rest of it. Very important, you got to keep it consistent. Alright, so see that? 3 to 9. How do I get from 3 to 9? Multiplying it by 3. That means I have to multiply all the quantities, the ratio quantities, with 3. So 1 times 3 is 3, 1 times 3 is 3, right there. Pretty easy, isn't it? Alright, good. Let Mr. Mac raise the board. Let's learn more. I'll be back in a few seconds. Alright, my dear student, let's take another scenario. Okay, let's say Mr. Mac, okay, to tell you the ratio of the balls in this bag, okay, is 1, 1, 4. And then I told you, okay, which is, well first let's define this one. 1, 1, 1, 1, 1, 4 is what? Okay, you got to tell. Okay, it's football, okay, football, and then shuttlecock, and then ping pong ball. Alright, so we know that. Okay, that's the ratio. Okay, ping pong ball. Now I told you this time the scenario is the difference between the smallest ball and the biggest ball is 6. Okay, so the difference between the smallest ball, alright, smallest minus the biggest is 6. And I want you to find the quantity of each balls inside this bag. Alright? Okay, so right now you don't know what the number is, okay? But you know the difference. Okay? The smallest ball to the biggest is 6. So what is the smallest ball? Of course, ping pong is the smallest ball, and the biggest ball is football. Alright? So we're going to take the difference, okay? 4 minus 1 gives you what? 3. So these 3 parts represent the 6, because that's the number of difference between the smallest to the biggest balls in the bag. Okay, this is the only information I gave you. I told you the difference between the smallest and the biggest is 6 balls. Alright? That means 4 minus 1 is 3. The 3 parts represent 6. Okay? So that means each part represents 6 divided by 3. So I take 6 divided by 3 gives me 2. So each part represents 2. That means 2 football, 2 shuttlecock, and I times this also by 2. Okay, I'm timesing everything by 2. So 2 football, 2 shuttlecock, 8 ping pong balls. Now look at that. Okay, that makes it 2, 2, 8. 8 minus 2 is 6. This is the biggest ball and this is the smallest ball. Smallest minus the biggest give me 6 balls. See that? So that's why I take the ratio, the difference of the ratio, and equal that to the 6 ball. That means 3 parts equals to 6. Okay, that means, let's see, we've got 3 parts, and I want to distribute that 6 into these 3 parts. Okay, so it's been 1, 1, 1, so 1, 2, 3, 4, 5, 6. So each has how many parts? How many balls? 2. So that's why the 6 divided by 3 is 2. Alright, that means each part is 2, 2, 2. So that means 1 times 2 is 2, 1 times 2 is 2, 4 times 2 is 8. So now let's look at it, okay? So we got 1, okay, 1 ball, 2 balls, okay, that's for the football, alright? So now, shuttlecock, 1, 2, see that? Now let's do the ping pong. 1, 2, 3, 4, 5, 6, 7, and finally 8. See that? Right there. 1, 1, 4. When you have 2 parts, it represent 1. So 2, 2, 8. Right there. Isn't that fun ratio? Alright, my dear student, that now you should be ready for your hands-on practice. Alright? Okay. Wow, let's see what Pablo's doing. He is busy putting the hands-on practice worksheet together. Alright, my dear student, give me the next few seconds. Let me erase the board and then we'll call Pablo out and then we'll have fun with hands-on practice. I'll be back with you in a few seconds. Bye-bye. Right, my dear students, are you ready for some hands-on practice? I know you are. Mr. Mac is ready too. Well, let's see, is Pablo ready? Yes, he is. Let's call him out. Pablo, come on over. Come on over, Pablo. Our dear students are ready for some hands-on practice. Alright, so hand over the worksheet so that they can start and work on the hands-on practice. Yes, my dear students, here's the worksheet. Have fun with it, and then once you're done, invite Mr. Mac in. Now be sure to pause the video. Here it is. Whoa, Pablo. Alright, let's do it. Alright, how did you do? Good? I know you always did good. Because why? Because you're the best. And you deserve the best. And that's why Mr. Mac is here, to bring the best. And it's coming from the best. Alright, my dear student, let's do it. Okay, the first one. The first one says, bucket below contains footballs, basketballs, and golf balls. Okay, state the ratio. All right, so you can see in the screen right now. So there are how many? 2 footballs, and then you got 2 basketballs, and you got 3 golf balls. All right, so let's do problem 1. So what's the ratio? Now the way it's given is what? Football, basketball, golf ball. All right, so that we know there's 2 footballs, and then 2 basketballs, and then very good, 3 golf ball. There you go, that's the ratio. All right, can you simplify? Can you reduce it? No, because there is no common number. You can reduce this too, but you cannot reduce that. That means you cannot. All right, it has to be all 3 reducible. In other words, a number that can be divided by. All right, so even though only this 2 can be divided by 2, but 3 cannot. So you cannot. You just leave it the way it is. All right, good. All right, let's do problem 2. Now problem 2 say determine whether the given ratios are equivalent ratios. All right, equivalent ratios. All right, so let's write that down. Problem 2a. 2a, you're given 3 to 2 to 5 and 12 to 8 to 20. All right, so we want to see if they're equal. Always good, take the bigger one and reduce it down to the smallest, so that way it's easier. All right, so let's see what is the common, the biggest common number that 12, 8 and 20 can be divided by. Well, let's see. How about 4? 12 can be divided by 4, 8 can be divided by 4, and 20 can divide by 4. See that? So let's do that. Let's divide all of them by 4. Okay, so 12 divided by 4 is what? 3. 8 divided by 4 is 2. 20 divided by 4 is 5. Let's see if they are same. Oh, it is. So what does that mean? These 2 are equivalent fraction. Yes, they are equivalent fraction. All right, okay, good. Now let's do problem B. Whoa, B, you're given 0.6 to 1.5 to 1.2 and 2 to 5 to 4. See that? Now look at this. This is all in the form of decimal. We cannot have a ratio in the form of decimal. All right, so what are we going to do? We're going to multiply all this by 10 or move the decimal by 1 time. So if I move 1s on this one, I also move 1 on this one, also 1 on that one. See that? So make sure all of them are in a whole number. Okay, by moving 1s, they all turn out to be a whole number. So that makes it this one 6, 15, 12. See that? All right, pretty much what I did. I times everything by 10. The same thing. All right, as long I times everything by 10, it's okay. It's still equivalent. All right, equivalent ratios. So 6, 15 and 12. All right, so now we want to reduce this to see whether it will come down to 2 to 5 to 4 ratio. So what do we do? Let's find a common number that all 3 of this can be divided by. So what about 3? Okay, let's divide, because 6 can be divided by 3, 15 can be divided by 3, and 12 can be divided by 3. So let's divide all this by 3. All right, okay, so 6 divided by 3 is 2, 15 divided by 3 is 5, and 12 divided by 3 is 4. 2, 5, 4. Yes, they are equivalent ratios. Now be very careful. Let's say, for example, if I were given like this, that's 2 different ratios. See that? This is 2 to 5 to 4. This is 2 to 4 to 5. Are these 2 same? Are they equivalent? No, they're not equivalent. They're not same. All right, because this is 2, 5, not 4. And then 4 and not 5. See that? So be careful. Okay, if I had given you like this, they're not equivalent. But since I give it this way, they are equivalent. So the arrangement, the order is very important. Okay, so 2, 5 and 4, just like this one we did. Football, basketball, and then golf ball. You can't mix it up. All right, okay, keep in mind. So that means yes, this is all, it's an equivalent. All right, so equivalent ratios. Good. Now let's do C. Now C are given 2 to 3 to 5 and 1 over 2, 2 1 over 4, and 3 1 over 3 over 4. Look at that, they're all in the form of what? Mixed numbers. Okay, you got fractions in there, so you cannot have like this either. So we're going to turn this into a whole number. All right, so what do we do? Let's convert all this into a improper fraction. When I say improper fraction, what method we're going to use? The semi-rotation method, alright? Okay, things that we learn from our Form 1, alright? Semi-rotation method. When you take a fraction, mixed number, you want to change it to improper fraction, you use the semi-rotation. That means you multiply first. 2 times 1 is 2, plus 1 is 3. So it becomes 3 over 2. And then use the semi-rotation. You multiply first and then you add, okay? 4 times 2 is 8, plus 1 is 9. So 9 over 4. And then again use a semi-rotation method. You multiply and then you add. 4 times 3 is 12. 12 plus 3 is 15. So 15 over 4. Now the next step is you want to get it the denominators, alright? Because you want it in a round number. Find a common number I can multiply. Or in other words, convert this into common denominator to this. So that means I'm going to multiply 2 to the denominator to make it 4. That means I also multiply the numerator by 2. So that makes it 6 over 4 to 9 over 4 to 15 over 4. So now they all have common denominator. So what can I multiply all these 3 to make it into a round number, whole number? How about if I multiply that by 4? See that? Because 4 and 4 will cancel out. 4 and 4 will cancel out. 4 and 4 will cancel out. See that? So that makes it what? 6, 9, and 15. Alright? See, now it became a whole number. So now I can reduce this to this. So common number that I can divide all these 3. Alright? So let me write this one here. 6, 9, and 15. What is the common number I can divide all these 3 by? Exactly 3, okay? Because 6 can be divided by 3, 9 can be divided by 3, 15 can be divided by 3. So 6 divided by 3 is 2, 9 divided by 3 is 3, and 15 divided by 3 is 5. It is equivalent. 2, 3, 5, 2, 3, 5. Yes, this one also, yes, equivalent, alright? Okay? All 3 of them turn out to be equivalent ratios. See that? So you learn how to, if there's just a whole number, how to find them. If it's a decimal and a whole number, how to decide whether the equivalent ratios, and a whole number and a fraction or mixed numbers, and you know how to find the equivalent fraction. Mr. Max has been using the word fraction. I don't know why. It's equivalent ratio, okay? If you've been hearing Mr. Mac using the word fraction, forgive me, it's a ratio, alright? So for some reason Mr. Mac keeps saying the word fraction. Equivalent ratios, alright? So they both are equivalent ratios. Alright, good. Alright, my dear student, let Mr. Mac erase the board and we'll do problem number 3. Alright, I'll be back with you in a few seconds. Alright, my dear student, problem number 3 says simplify the below ratios to the lowest term. Alright, so problem 3a. So we're gonna, the ratio is 35 to 49 to 63. See, that's why a timetable comes so handy. If you look at this 35, 49, and 63, what is the number that all 3 of this can be divided by? 7? Yes, it is 7. Alright, good job. Okay, because you know in timetable 7 timetable 35 is in there, 49 is in there, and 63 in there, because we know 5 times 7 is 35. That means 35 divided by 7 is 5, 49 divided by 7 is 7, and 63 divided by 7 is 9. There we go. We simplified it right there. 5, 7, and 9. You can't reduce any further. That's it. See that? That's the purpose, to bring it to the lowest, alright? Okay, let's look at B. B, you're given in a form of fractions. So it's 2 over 3 to 1 over 2 to 3 over 4. Alright, so what do we do? Exactly. We want to get rid of the denominator. That means we've got to make it all common denominator, okay? 3, 2, and 4. What can you think of common between 3, 2, and 4? A number that can be divided by all these 3 numbers. How about 12? 12 can be divided by 3, 12 can be divided by 2, and 12 can be divided by 4. Alright? So that means we're going to make this into 12, all the denominator. That means what times 3 give me 12? 4. If I times the denominator by 4, numerator also have to times by 4. So 2 times 4 is 8, 3 times 4 is 12, alright? So what about this one? We times it with 6. 2 times 6 is 12, alright? That means I times the numerator also by 6. Very important things we learn from our fraction. See that? Things that we learned from previous lesson are very important. That's what's the beauty about mathematics. Everything is built on top each other. That's why Mr. Max strongly encourage you have access to Form 1. Be sure to go back to your Form 1 lessons on fractions. Make sure during in between you're learning Form 2 mathematics lessons. Go and do Form 1 as well. Refresh things that you learn. Especially if you're new with Mr. Mac, you have access to Form 1 lessons. Go and learn it. Alright? Because a lot of things that I taught in Form 1, I use the terms in Form 2. So sometimes you may find it, what did Mr. Mac mean by that? Because I already used it in Form 1. Alright? Okay, good. So 1 times 6 is 6. Now what about 4? 4 times what? Give me 12. 3. That's good. That means I'm going to times the numerator also by 3. Okay? So we know 4 times 3 is 12. 3 times 3 is 9. Now, in order to eliminate 12, the denominator, I can multiply all of them by 12. That's right. 12 times to the 12 times to the 12. Why is that? I can cancel 12. See that? See that? I can cancel. Alright? So that makes it 8, 6, and 9. Now, is it reduced? No, we just got rid of the fraction. Okay, look for a number that 8, 6, and 9 can be divided by. Well, 8 is an even number. 6 and 9 is a 8 and 6 is an even number. 9 is an odd number. Definitely 2 you cannot, alright? Or 3 you cannot. So look like you cannot reduce. Now you said, Mr. Mac, 8 and 6 can be divided by 2. No, no, no. You gotta have all 3 of them divisible by the same number, not just this one by 2 and this one by 3. You cannot do that. Alright? You have to have a number that all 3 of them can be divided. There is no number you can all 3 can be divided. And that's it right there. You reduced it. That's it. See that? Pretty easy, isn't it? Alright, good. Alright, let's look problem C. Now C, you're given, alright, so 0.2 ratio, 0.12 ratio, 0.16. Look at that. They're in a form of decimal. Alright, what are we going to do? Well, this one only got one number behind the decimal, but this one got 2 numbers behind the decimal, and this one got 2 numbers behind the decimal. That means you want to make this whole thing to be a round number, but equally. See, you always want to take the biggest number of numbers behind the decimal, which is 2 in this case. I want to move it twice. 1, 2. That means this also moved twice. 1, 2. That means this one also moved twice. 1, 2. See that? So that becomes the 2 is in the first bubble. That's nothing. Then you put a 0 in that bubble. So that makes it this one 20 ratio 12 ratio 16. See that? Alright? Pretty much I'm multiplying everything by 100. That's what I did. Moving the decimal is pretty much I'm multiplying 100, 100, 100. 0.2 times 100, which is 20. 0.12 times 100, give me 12. 0.16 times 100, give me 16. Are we done? No, we have to see if this one can be reduced. I just converted the decimal into whole numbers. So now can you divide 20 by, let's see, how about 4, 4, and 4? Because 20 can be divided by 4, 12 can be divided by 4, 16 can be divided by 4. Alright? What does that mean? 20 divided by 4 is 5. 12 divided by 4 is 3. 16 divided by 4 is 4. There you go. That's the reduced ratio. Pretty easy, isn't it? Alright? See that? Keep in mind. Even though this one only one number behind the decimal, there's 2 numbers behind the decimal. You want to go to the number, that bigger number of numbers behind the decimal. Alright? Because you want to make them into a whole number. So I have to move twice instead of once. So this I have to move twice. I add another 0 behind it, which makes it 20. Okay? Pay attention to that. Alright, good. Well, let's do problem number 4. Let Mr. Mac erase the board and I'll be back with you in a few seconds. Alright, my dear student, let's do problem number 4. Okay, problem 4 says find the ratio of x to y to z and given. Okay, so 4a. Alright, so 4 we want to write in a form of what? X, y and z. Alright, in 3, okay, in a 3-4 ratio. Okay, 3 form. Alright, and so a, you're given what? You're given x to y is 3 to 4, and then they give you and y to z equals to 4 to 7. All right, so we want to combine that in a form of x, y, z. Look at that, x, y, y, z. That means you only got 3. 1, 2, 3. There's a repeat there. All right, so we want to see what the relationship between x, y and y, z. All right, now look at that, 3 and 4. The 3 belongs to x, 4 belongs to y. See that y is 4. That means the 4 and 4. That means I can write this way, x, y, y, z. All right, we know x is what? 3. Y is 4. Both are 4, so I can put 4. And z is 7. So that makes it 3, 4, 7. So you use the line up method. Okay, so we're going to line it up. All right, with the y and y, okay, the identical one, the one that repeating one, you lined up, and make sure they are same number. All right, same ratio, 4 and 4. All right, okay, let's do another one. All right, let's say problem B. B, this time you're given x raised to y is 5 and 7, and then and y and z is 14 and 15. All right, so we got y and y, so we can line it up. So x, y, y, z. All right, now wait a minute, look at that, x is 5, all right, z is 7, well, I mean y is 7, but in this case y is 14 and z is 15. They're not same, so I got to make them same. So in this case I can see if I can reduce this to be 7, but 15 cannot be reduced. I cannot divide 15 by 2 because I can divide 14 by 2 but not 15. But what about this one? If I multiply this by 2 becomes 14. I go the other way around. Alright, that means I have to multiply x also by 2, the 5 also by 2. So that makes this one, so it becomes 10 and 14. So now they both are same. Now I can write down 10 ratio 14 ratio 15. See that? The goal is y and y must have same ratio number. Alright, the quantity has to be same. 14 and 14. Earlier 7 and 14. So we cannot combine them into x, y, z. So until I make them to be identical, then I can combine them. Alright, what I did? I multiply this by 2. If I multiply y by 2, x also has to be multiplied by 2. On the same ratios, alright? So that makes it 5 times 2 is 10, 7 times 2 is 14. Now 14 and 14, there you go. Pretty easy, isn't it? Alright, good. Is this the final answer? Yes, because I cannot reduce it. 10, 14 and 15 is the final answer. Alright, good. Alright, let's do C. Now C you're given x, y is 6, 11, and then x, let me write down here, okay, x, z is 3, 5. Alright, now look at this. See that x and y is 6 and 11, 6 to 11, and x and z is 3 to 5. It's the x, and x is the one you want to compare now. Make sure there's 6 and 6, but this one's 3, but this one's 6. Can I reduce this down to 3? No, because why? I can divide 6 by 2 but not 11. But can I increase this to be 6? Yes, I can multiply this by 2, I can multiply this by 2. So that makes what? This one will be 6 ratio 10. Alright, so now we want to put x to y to z. Alright, always keep it in the sequence. So we know what's x. X is 6. So I'm going to put 6. And what is y? Y is, so in this case y is 11. And z is, it's 10. Make sure you take this one because we multiplied this into 2. So 6, 11 and 10. Very important, okay? Pay attention to that, not 5. Alright, because we doubled the 6, the 3 to 6, that means 5 becomes 10. So z new value is 6, z's new value is 10. Alright, There you go, right there. That's the answer. All right, pay attention to that. Okay, good. All right, good. Let Mr. Mac raise the board again, and we'll do problem number 5, and I'll be back within a few seconds. Alright, my dear student, problem number 5. So word problem. Alright, how do we solve word problems? Read it as though you want to understand the question, and look for things that's given, and look for also for things they want us to find. Alright, let's do problem number 5. The ratio of cows to goats to chickens in a farm is 5, 9, 12. So 5 to 9 to 12. If there are 108 goats in the farm, find the number of cows, the number of chickens. Alright, so let's write that down. Problem 5, you're given the ratio, okay? The ratio of cows to goats to chickens. Alright, to chickens. Okay, and what's the ratio? It's 5, 9 to 12. Alright, so that's the ratio. And then they told you if there are 108 goats in the farm. So there are 108 goats in the farm. So find the number of cows, and then find the number of chickens. Okay, so in other words, 108. See that? Goats. They said 108 goats in the farm. So now we want to find out what would be the cows and what would be the chickens. Now, what times 9 gives me 108? One way of doing it, you take 108 divided by 9. That what tells us what times 9 gives you 108, and we know it's in our timetable range. 9 times 12 is 108. 108 divided by 9 is 12. Okay, in other words, I'm multiplying it 9 with 12. If I multiply 9 by 12, I also have to multiply 5 with 12 and 12 with 12. See that? So that means 5 times 12 is, very good, 60. 12 times 12 is 144. So that should be able to answer our question A, the number of cows. Number of cows, how many? A, it's 60. Alright, cows. And then B, the number of chickens, 144 chickens. Okay, pretty easy, isn't it? Straightforward, very straightforward. Alright, see that? You line them up, and then you find out from 9 to 108. So that means like 9 times 12 gives me 108. If I times 9 by 12, I have to times 5, and also 12 also by 12. Times them with 12. There you go, we got it. Okay, good. Let's do problem number 6. The number of white, black and red marbles in a jars in a ratio of 7 to 4 to 14. If the total marbles in the jar is 75, find the number of white marbles, the number of black marbles, and the number of red marbles. Okay, so let's write down the ratio. Okay, 6. You're given first white to black to red. Alright, and the ratio is 7 to 4 to 14. Now you know that you're given the total of marbles, which include white, black and red, is how many? 75. So the total is 75. So we know the total is 75. That means if I had to add 7, 4 and 14, that's exactly the parts, number of parts that represent 75. Proportion. Alright, so let's add them. 7 plus 4 is 11. 11 plus 14 is, so 14 plus 11, 4 plus 1 is 5, 1 plus 1 is 2, so 25. Alright, so that means 25 represent 75. Alright, so 25 parts in 75. We're going to break that 75 into 25 parts. That means what? 75, we're going to divide that in with 25. Okay, so we're going to take 75 divided by 25. Okay, so now let's use the long division method. So we're going to use exactly the cage approach. 75 is kind of into Mr. Mac, I'm going to put it inside the cage, and 25 is kind of out from Mr. Mac, I'm going to put outside the cage. Alright, so 7, you can go to the next digit. 75, that's how many? 25. And we know 3. 3 times 5 is 15. 5 carry 1. 3 times 2 is 6. Plus 1 is 7. See that? 75 minus, give me 0. That means each part represent 3. That means 7 represent 3, 7 times. That means 7 times 3. See that? 7 times 3, 4 times 3, 14 times 3. That's how you do it, okay? So 7 times 3 is what? 21. 4 times 3 is 12. 14 times 3 is outside a timetable range. So let's put 14 times 3. 3 times 4 is 12. 2 carry 1. 3 times 1 is 3. Plus 1 is 4. So it's 42. So it's 42 right there. Now if you to add them, total up, will give you 75. Okay? So whenever you're given the total and with the ratio, you add that total of the ratio, you divide with the total that was given, and that will give you 1 part's equivalent number of marbles. Okay, so in other words, there are 7 parts, 4 parts, 14 parts. In other words, 7 parts of white, 4 parts of black, and 14 parts of red. When I add them, give me 25 parts. Alright, a portion. Alright, so that means each 1 represent how many out of the 75? So I take 75 divided by 25, which gave me 3. Right there from this, 3. Okay, that means each part represent 3. So 7 times 3 is 21, 4 times 3 is 12, and 14 times 3 is 42. Alright, good. So that tells you what? How many white? 21 marbles. That ends our problem number A. White, A is 21, B is 12, which is the black, and C is 42. White, black, and red, and that's what they want us to find. Alright, so pretty straightforward, isn't it? Okay, good. Well, let Mr. Mac erase the board and we'll do the final one, problem number 7, and I'll be back in a few seconds. Alright, my dear students, let's do problem number 7. Okay, the problem number 7 says, in a city, the ratio of low income to middle income to high income earners, alright, is 3 to 5 to 2, alright. The difference between middle income and high income earners is 720. Find A, the number of low income earners, B, the number of middle income earners, and C, the number of high income earners. Alright, okay, so question 7, it's kind of talk about 3 different income earners, alright, which is low income, middle income, and high income. And the ratio is what? So 7, the ratio was given was 3 to 5 to 2. And this is the low income, and this is the middle income, and this one is the high income, alright, earners. And they say the difference between the middle income, okay, middle income minus the high income, because the difference means you're taking the difference, you're subtracting middle income with the high income, alright, which is mean what? 5 minus 2, which is what? 3. And they told you that 3 parts is the one 720, because they say that the difference between the middle income and the high income earners is 720. See that? 720. So the difference, that means the difference of middle income with the high income, the 3 parts represent 720. Okay, so 1 part represent what? So if we 3 parts represent 720, 1 part, how do I go from 3 to 1? I divide by 3. That means I divide this also by 3 to get to 1 part. Okay, so I take 720, I'm going to divide that by 3. We're going to use the long division method. Okay, we're going to use the cage approach. 720 is kind of into Mr. Mac, I'm going to put inside the cage. And 3 is kind of out, I'll put outside the cage. Alright, in 7 there's how many 3? 2. 2 times 3 is 6. 7 minus 6 is 1. Bring the 2 down. In 12 that's how many 3? 4. 4 times 3 is 12. Minus, give me 0. That means there's a 1 0 in the back. Bring it up. Because this one came to 0, left 0, bring it up. Alright? Okay? So that means 240. 1 parts represent 240. So in this case, you got 3 parts. That means what? 3 times 240. That means 3 times 240, 5 times 240, 2 times 240. See that? So that should answer our question. The problem that asking for us, the number of low income earners. That means 3 times 240. That's the low income. So A, 3, another word, 240 times 3. 0 times 3 or 3 times 0 is 0, 3 times 4 is 12, 2 carry 1, 3 times 2 is 6, plus 1 is 7. So there are 720 low income earners in that city, okay? Now let's say B. B is the middle income. So middle income is 240 times 5. So 0 times 5 times 0 is 0, 5 times 4 is 20, 0 carry 2, 5 times 2 is 10, plus 2 is 12, okay? So there are 1,200 middle income, alright? And C, which is 2 times 240, so we can put 240 times 2, 0, 2 times 0 is 0, 2 times 4 is 8, 2 times 2 is 4. So there are 480. So 720, 1,200, and 480. Low income, middle income, high income earners. That's the answer right there. You got it? Good job. I'm so proud of you. Mr. Max always proud of you. You know why? Because you're the best. You're always the best. And you belong to the best, which means score a math victory. And I'm so proud of you. You work so hard. Now, do you know this is the end of our lesson? And you worked so hard, Mr. Max is so proud of you. Here you are. Learned the whole thing that you need to know about ratio, rates, and proportions. That's a lot to learn, and you did a great job. You stick with Mr. Mac all the way to the end to learn this lesson. Well, my dear student, I assure you, you're going to do so well. You know why? Because you're the best. And that's why Mr. Mac is here, to bring the best. Because you deserve the best. And it is coming from the best. Yes, my dear student. I'm proud to be your teacher. And I'm so proud to have you my student. Because you're very dear to Mr. Mac. Well, here's Pablo. He already reminded us it's time for hands-on. No, it's time for quiz. We just did hands-on practice. It's time for quiz. Alright, my dear student. Have fun with the quiz and come back and see me in the next lesson. I'll be here waiting for you. You mean a lot to me. I wanted to bring the best for you. That's why I'm going to be here waiting for you to come and learn on the next lesson. Have fun with the quiz. Bye-bye.